Okay, you're welcome back to the class. Now we're talking about the simplification of surds. Why is it important to simplify surds? Okay, in the last class I explained to you that like surd or for instance, if I have something like a root m plus b root n, we can simplify them further by combining them to get a plus b root m because they're what like surds. Now sometimes you might have two different surds. Imagine having something like this. Root 45 plus root 5. You might assume, oh, nothing can be done. We can't add this. They are not like surds. But they are actually like surds. The only difference is that this one is not simplified. Okay? If it is simplified, you actually find out that you can add them. So that's why it's important to simplify. It's just like fractions, reducing fractions to their lowest term. So it's also important to simplify surds to their lowest possible values. Okay, so now let's see how we can simplify this. If we have root 45, don't forget, and the rules for surds, we say root m times root n is equal to root n times n. In other words, if you have root n times n, you can also separate it to get root m times root n. So that's what we're going to do here. Root 45 is equal to root 9 times 5, since 45 is 9 times 5. Okay? And that would give us root 9 times root 5, which is the square root of 9 is 3. So it will give us 3 times root 5. We can just write it as 3 root 5. You see, after simplifying it, you can realize that these two are similar surds. So this will be 3 root 5 plus root 5. And that will give you 3 root 5 plus 1 root 5. That will be 4 root 5. You see why simplification is important? Okay, now let's take other examples. Number 2, root 162. If we simplify it, we can actually say 162 is the same thing as square root of 81 times 2. Okay, so that will be root 81 times root 2. But 81 is a perfect square. That means root 81 will give us 9. So that will be 9 times root 2, which is 9 root 2. Okay? Okay, what if we have something like this? Like that of a number 3. We have a 3 root 50. There is one outside already. Sorry, 3 root 50. So let's try to simplify the one we have in the root sign. That will be 3 root 50 itself. We ask ourselves, which perfect square can actually divide 50? You know, perfect squares are numbers you get when you multiply whole numbers by themselves. Like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So if you look at it, excluding 1, 4 cannot divide 50, 9 cannot divide 50, 16 cannot divide 50, but 25 can divide 50. So we go with 25. So root 50 is the same thing as 25 times 2, which means 3 times root 25 times root 2. And that will be 3 times square root of 25 is 5 times root 2. And that will be 3 times 5, 15 times root 2, 15 root 2. So this is what we need to understand about simplification of surds. Now that we've understood simplification of surd, we can apply this in addition, subtraction, multiplication, and division of surds. Okay.